After you've collected data from a random sample, you can use that data to make an inference, which is a prediction or an estimate, about the total population. When making these inferences, we make proportions and solve our proportions to find out a value about the entire population. The example on your screen says you're going to produce tennis shoes that come in 3 different colors. In order to decide how many to make in each color, you conduct a survey. Of the 300 people you survey, 25 said that they would purchase yellow shoes. If you're going to make 10,000 pairs of shoes, how many should be yellow? To make a proportion here, I would think about what I know. I know that 25 people said that they would get yellow shoes. So 25 people indicated that they would get yellow shoes in my sample. That was 25 people out of 300 total people. So the ratio that I'm going to start with is 25 people said they would get yellow out of 300 total people in the sample. Next, to make my proportion, I'm going to set it equal to another ratio. My question is asking how many should be yellow, which means I don't know how many pairs of shoes I'm going to make yellow. So since I have yellow in my numerator for my first ratio, I'm going to have yellow in my numerator for my second ratio. Since I don't know how many are going to be yellow, I'm going to use a variable, so I'll use x to represent the total number of yellow shoes. Now, I know that I'm going to make a total of 10,000 pairs of shoes, so that's going to go in the denominator since my total was in the denominator for my first one. Now, to solve, I can make an equation by cross multiplying. So I can multiply 25 times 10,000, which would give me 250,000. I'm going to set that equal to the next part of this, which I'll do x times 300. X times 300 gives me 300x. Now I'm just going to solve like a normal equation, and I'm going to get x by itself. To get x by itself, I'm going to have to divide by 300 on both sides of this equation. When I divide 250,000 by 300, I get 833.3, and this 3 repeats, or this is the same as 833 and 1/3. On this side of my equation, 300 divided by 300 will make 1, so they cancel out because 1x is the same as just x. Now, this means that the value of x is going to be 833.3 repeating. However, I know that I can't actually make 0.3 or 1/3 of a pair of shoes. So, in this case, I would have to round. And when I round this, I would get that I would have approximately 833 pairs of shoes should be yellow. Now, this is only an approximation because this is based on the data from the sample. When we make inferences, we can make good estimates about the total population, but we can't be certain that those estimates are going to be exact. Next, we see suppose 3/5 of people surveyed approve of the governor. How many people would you have to select randomly on average in order to get 20 people who do not approve of the governor? The first thing we need to understand is what 3/5 means. If I say 3/5 approve, this means that 3 people approve of the governor out of 5 total people. So, for every 5 people that you survey, 3 of them approve of the governor. This means that since 3 approve out of 5 total, there are 2 who do not approve out of every 5 people. So now we need to look at our question. Our question asks, how many people would you have to select in order to get 20 people who do not approve? So since I'm looking at do not approve, I actually need to look at this 2/5 instead of my 3/5. So I'm going to start with my ratio of 2 don't approve out of every 5 total people. And then let's look at what my question asks. We want to know how many people would you have to select. So how many people would you have to survey in order to get 20 people who do not approve? Well, I want 20 people who do not approve. And if I look in my first ratio, my number of people who do not approve is in my numerator. So I'm going to have to put 20 people who don't approve in the numerator of my second ratio. What I'm looking for is how many people I would have to select. So I don't know how many total people there would be, so I will use the variable x to represent that. Now, there are several ways I could solve this. I can look at this and understand that these are equivalent ratios, which means that to get from 2 to 20, I would have multiplied 2 times 10, which means that to get from 5 to x, I would also multiply 5 times 10. And when I multiply 5 times 10, I get that x equals 50. You can also solve your proportion by cross-multiplying and setting up an equation. So if I did that, I would do 2 times x, which would give me 2x, and then I would put my equal sign, and then 20 times 5, which would give me 100. To get x by itself, I would need to divide by 2 on both sides of this equation. These 2's would cancel and leave me with x equals, and if I do 100 divided by 2, I would get 50. This means that you would need to sample about 50 people, or you would need to sample, about 50 people in order to find 20 who do not approve of the job that the governor is doing. Next, we see suppose 3/4 of people surveyed support changing the legal driving age to 18. So if we start with that, if we say 3/4, that means if it says 3/4 support changing, that means that 3 people support changing the law out of every 4 total people. This means that 1 does not support out of every 4 total people. Now, my question asks, how many people would you have to select randomly on average in order to get 60 people who support changing the legal driving age? So for this one, we are looking for those who do support, which means we're going to use our ratio of 3/4 since 3 is the ratio that has the supporting data. So I know that 3 support changing the legal driving age out of 4 total people. And then my question says, I want to find 60 people who support. Since my people who support is in my numerator for my first ratio, then 60 people who support should be in the numerator for my second ratio. What I don't know is how many total people that will be, so I'm going to put a variable here. And now I can solve. I know that to get from 3 to 60, I would multiply by 20. 3 times 20 gives me 60. So to get from 4 to x, I would also multiply by 20, and 4 times 20 would give me 80. You can also, in this case, you can cross multiply and make an equation. So if I did that, I would do 3 times x, which would give me 3x, and 60 times 4, which would give me 240. Then to get my variable by itself, I would need to divide by 3 on both sides, and these would cancel, and I would get x equals 240 divided by 3 is 80. So whichever method you choose, you're going to find the same answer. This means that you would need to survey approximately 80 people in order to find 60 who do support changing the legal driving age. Now, again, this is an approximation because just because we survey 80 people does not mean that we're going to get exactly 60 who support changing the legal driving age, but it is a good inference to make based on the data that we have from the sample. Next, we have a large bag of candy that contains 800 Skittles. A random sample of 20 Skittles from the bag contains 7 red, 5 green, 3 yellow, 3 purple, and 2 orange. What is the best estimate of the total number of orange in the bag? Well, for this, we need to look at what we know. So we're looking for orange in the bag, and I know that from my random sample, there were 2 oranges in the sample. So I know that I have 2 orange in my sample, and that is out of a total of 20 Skittles that were in the sample. So there were 2 oranges out of 20 total in the sample. I want to know how many oranges are in the whole bag. So since I have orange in the numerator, I'm going to have orange in the numerator here, and I don't know that number, so I'm going to use X to represent it. And I need to know my total number of candies in the bag. I had 20 total in my sample, and I have 800 total in my bag. Now I can use any method I choose to solve. So if I look at 20 to 800, I know that 20 times 40 gives me 800. So to get from 2 to x, I can multiply 2 times 40, and that would give me x equals 80. I can also cross multiply, so 2 times 800 gives me 1,600, and x times 20 gives me 20x, so I would say equals 20x. To get my variable by itself, I would divide by 20 on both sides. These would cancel and leave me with x equals, and when I do 1,600 divided by 20, I get 80. So for both of these, whichever method you choose, you're going to get 80 as your answer. So we can say there are approximately or about 80 orange in the bag. Finally, an average home game for the Wildcats brings in a crowd of 1,200 people. A random sample of 30 people at the entrance gate reveals that 24 will be supporting the Wildcats and 6 will be supporting the visiting team. Approximately how many fans at the game will be supporting the Wildcats? Well, I'm looking for how many are supporting the Wildcats. So from my sample, I know that 24 support the Wildcats. And that's out of a total of 30 people in the sample. So the ratio I'm going to start with is 24 people support the Wildcats out of 30 total people in my sample. I'm going to set that equal to another ratio. I know that I'm looking for how many people are supporting the Wildcats. So since I know that that's what I'm looking for, I can put a variable for supporting, since I don't know that number. And then I need to know the total number of people in the crowd. Well, I know that the crowd will be a total of about 1,200 people. So now I can solve. I know I can use any method. I know that if I go from 30 to 1,200, I would multiply 30 times 40 to get there. So to get from 24 to x, I can multiply 24 times 40. And if I do that, I get that x equals 960. I can also, if I don't know how to do this, I can always cross multiply. So I can do 24 times 1,200, which gives me 28,800. And then I would set that equal to x times 30, which is 30x. Now to get x by itself, I would divide by 30 on both sides of this equation. My 30s would cancel and leave me with x. And then 28,800 divided by 30 gives me 960. So whichever method I choose, I'm still going to get 960. So we would say that there would be about 960 people at the game who support the Wildcats.